We're here this evening to talk about editing your data offline and online with the ArcGIS Runtime. My name is Justin, and I'm here with Auntie, and a special guest appearance by Eli from our example apps team to walk us through some code later this evening. So, all right, what are we going to cover today? So we're going to take a little bit of a look at the ArcGIS platform and some of the infrastructure needed, and talk a little bit about what's needed to actually power working with data and editing data inside of the runtime. We're going to cover the APIs and the capabilities in the runtime to be able to do this. And we're going to spend some time looking at some of the new functionality that's gone in recently, working with maps and layers for synchronization and taking them offline, transactions, and some of the new data formats that support editing we'll talk about. So there's a couple of things that aren't covered though. Earlier today we had a demo theater where we took a whirlwind tour of how you enable all of your data for offline use in the platform. So we're not going to talk about authoring services and enabling them for sync and that kind of stuff, but those are important things that need to be done. We're going to really assume at this point in time we're talking about sync-enabled feature services, that step has already been done. And we're also not going to cover about kind of the data distribution, the different models and patterns for taking your data offline, because we just covered that in a working with maps offline session, which ran right before this one. I see some familiar faces here, and we'll run again tomorrow afternoon at 1 p.m. We got all of the best session times right before the party and after closing. I'm not sure who we angered, but yeah, something went wrong this year with our schedule. But tomorrow afternoon there'll be a repeat of our working with maps. And that session really covered about how you leverage the map inside of the platform, take that offline, and start to work with it. So that was kind of two precursors to where we're going to pick up from this afternoon and continue on about how you edit data and work with data inside of the runtime. So, when we work with data, when we work with the runtime, there's two kind of patterns that we talk about for offline usage. There's a services pattern and there's a desktop pattern. And both of these patterns leverage the power of the ArcGIS platform to be able to support creating data and providing data to the runtime to use it. With this pattern and the services pattern, we're really leveraging online and your portal to be able to serve up services and items that you can use inside of your app, that you can take offline and then potentially make edits and synchronize back. So building upon the services and the data that's part of the platform, we are able to build layers that sit on top of that leverage that data. And those layers have their own capabilities and their own configuration. So I can, when I author a feature layer, for example, I put a certain set of symbology with it. I can include things like a pop-up definition. So these are things that I can now, with that layer, be able to reuse it multiple times across the platform in multiple products to get a consistent look and feel. And once I have those layers, I can then combine those layers into maps and scenes, which again, bring together those layers in a certain way with a certain look that then can be used in runtime, used on the web, and used inside of Pro. So really, this is leveraging the geoinformation model where the map is the central component of it to be able to transfer a consistent look and feel and behavior throughout the whole platform. So in the past, when we've talked about going offline and editing data, we've kind of talked about it from a services standpoint, where you publish a bunch of services with your ArcGIS server, or maybe they're hosted feature services, and you consume those services directly inside of your app. Using the geodatabase sync task, you can take them offline, and then you make your edits and you can synchronize them back. But as we expand the capabilities inside of the runtime, we're really shifting to more trying to think about how we can best leverage maps. So still having those same backing services, but now wrapping those up in a map and consuming that map inside of your applications. So this really allows you to leverage the power of the platform. So I mentioned in the previous session that, like, if I want to change the symbology on my map, before I might have had to actually go into code, make all the changes there, redeploy my app, which fine if we're just messing around, but if you're actually using this in a production environment and a redeploy is to thousands of users, there's a huge implication with that. By leveraging a map, we're now able to modify that in the back-end system, be able to change the symbol, maybe even edit a pop-up, and then that automatically can be picked up by the apps out in the field. And if you had, say, a web app used in a connected environment, it could leverage the exact same symbology, the same pop-up, so you get that consistent look and feel. Taking that even a step further, is you can also, as I said, we author those layers with their own set of capabilities and their own set of information. Those layers can be used inside of multiple maps. So you can have configuration set up specifically for these targeted use cases that you want for specific apps. Again, leveraging a map that you can use in multiple places, but having a shared set of layers and potentially data behind that. So if in one application I need to send people out in the field to do inspections of some kind of data, but I have another group of people who I just want to only have read-only access and just get the latest version of that. It's all about leveraging the back-end services that we have in the GIS. So what can I edit? We have a number of different types of data that we support editing on. We have our feature services that we've talked about already. We have sync-enabled geodatabases, so those generated from the feature services now living on a device as a mobile geodatabase. We also support editing of feature collections. Feature collections may be hosted in your portal or online as a standalone item, or may be hosted or may be part of your map. And these support editing. There are some considerations if you're going to be editing them. You're editing the whole thing and it doesn't support sync. You edit it and you save it back, so it's a replace if it's an item. But they potentially scale well for large amounts of data where you don't want to have or don't need everything stored in the geodatabase, or you have a map that's potentially going to go viral in an app where you have all of that stored more at the web tier than going back to the back-end database. So they have their place and they can be used for certain things, but for workforces where you want to support synchronization, these wouldn't be the first choice. Another classic format that we now have support for that supports editing. Again, lots of different workflows where you can envision editing of shapefiles being potentially useful, especially with interfacing with other pieces of software out there outside of ArcGIS, where the shapefile is a rather standard format. And speaking of standard formats, the OGC GeoPackage specification is another data format that we've added in the 100.2 release, so last November's release of Runtime. We've added in support to be able to work with, including editing, GeoPackages. And then you can use those in other open source tools, other parts of the platform. So just another option for editing and working with data. But the nice thing about these 5 different pieces of data is they're all just feature tables from an API standpoint. So it doesn't matter where they're coming from, what the actual backing piece is, you get a consistent look and feel by leveraging the feature table and working against features. Now I mentioned features, but we also have this thing called a graphic. And what's the difference between the two of them? So a feature is something that is persisted in one of those different layers and backing data sources that we talked about. And inherently, it's persisted in that and it's part of your map. It's one of the layers in your map. With a graphic, we think of them more as kind of transient things that can come and go. Maybe it's the route or a search result or something that comes in that is not persisted. They are on top of all the layers in your map. Your graphic overlays are there. You can add graphics into it. They still have attributes and symbols. There's still a geo element, which is an interface implemented by both graphic and feature. but they're not part of the map. There is no persistence for those. They exist for the lifetime of the app unless you write your own code to do something with those and to bring them back. Really, for persistence and for data that's going to have a longer lifespan, we think of these as features and we want them part of our map. So a quick high-level overview of the API that we work with. We start with the feature table. And as we said, all of those data sources we looked at, they're all feature tables. And on the feature table, there's a number of different basic kind of properties that we can look at. There's being able to look at the capabilities of, do we even support add, updates, and delete, those basic kind of CRUD operations for working with these things. And then querying features, because that's kind of, if you can't get a query out of one of those tables, there's really not much else you're going to be able to do with it. When you query features, you get a feature. And a feature implements a GeoElement interface, giving it those basic capabilities of having a geometry, so its spatial component, and a set of attributes that you can work with. To render, when we looked at the feature table, none of this is actually dealing with rendering at this point in time. If you want to bring the feature table to life inside of your application, inside of your app, you do that through a feature layer. So all of those feature sources that we looked at, their feature tables are assigned to a single feature layer. So we don't have a shapefile feature layer and a geo-package feature layer and et cetera, et cetera. We just have a feature layer that can take any one of these kinds of tables. And on the feature layer is where we get into all of the rendering information, so we can define our symbols and renderers used for the display of that. And we can do things to reduce the amount of draw time elements that we have by doing things like having a definition expression on our feature layer. This doesn't affect any of the data in the feature table, it just affects what we're actually seeing at that time. Now, as we said, the feature table is kind of that base that all of our different feature sources implement. With the ArcGIS services that we have, so mainly the feature service, there's some additional capabilities that we know this supports. So with the ArcGIS feature table, this is where we get into having information about the layer info, ownership-based access control, editor tracking, and where we also advertise things like templates and types. So all of this comes in at the ArcGIS feature table. And then we also have a matching specialization with the ArcGIS feature, because again, we know the features coming from the platform support things like attachments. And we also have implemented our loadable interface. So if you've worked with any of the new versions of the runtime, you'll notice that we've introduced a loadable concept that we use across most of the API. It's slightly different on each of the products. .NET does it, still has a loadable pattern, but it looks slightly different than the loadable pattern, say, in the Swift code that we're going to see, but the concept is still the same. And for a feature, it's very important because you're able to get just a subset of the attributes that you need from a potentially very large feature, and you just get the things that you need for display purposes. But before you go to edit it, or before you maybe show it in a table, you can then load that feature and go make a request to get all of the rest of the data to back it as well. So it's ways to be able to have a nice, lightweight, responsive UI and be able to then kind of do paging and to do just real-time fetching of the data and still build something that works very seamlessly. So we have, most of the time, we're actually working with the ArcGIS feature table if you're working with feature services. But depending on if you're working online or offline, there are a couple of things that we need to do slightly differently. So we do have a service feature table where the main thing is we need to call apply edits when we're doing editing of data. Or with the geodatabase feature table, which is what we're using when we're in a disconnected or offline, we are working with a backing geodatabase. So there's a get geodatabase or something similar on each of the APIs, and which is where you would then call synchronize, and it points to where all of that data is stored. So it's important to understand this model because it can define how you build your tools that you're going to work with. If you want to build a generic set of editing tools, you can target building that works with the feature table and with features. So now it doesn't matter what the feature source is, you can have a nice editing tool that does all of your customized special things and work with any of those different feature sources from anything. If you know that you're going to be working with the ArcGIS features, then you can have more specialized things there where you might bring in a nice attachment tool for attaching features and collecting photos that work with the features. So really looking at how you can leverage this and design generic tools. It also means that you can create tools that work both online and offline. So because it is just a feature you're working with, it doesn't matter if it's connected or not, you can have one editing tool regardless of the connection of the app as well. So working with connected layers, there's a number of different capabilities that the layers and the services advertise. And we looked at a little bit of this in the Preparing Your Data demo theater earlier today about as you make changes when you have these services published or to the items inside of online, it affects the capabilities of those services. And then inside of the runtime APIs, there's a series of properties that can tell you what is actually advertised and what actually works for these features. So these are can add, can delete, can update, and can edit geometry. So these are the properties that you can leverage when you're building these generic tools, that if you're working with features, you can check to see, does this thing allow geometry edits at all? And if it does or doesn't, you can change and adjust your UI to show a set of geometry editing tools. Or don't show the plus button in the first place if we know that you can't add any new features for this particular feature table that you're working with. One of the other pieces that are advertised by the services and are pre-authored as you publish the services are working with feature templates and feature types. So the feature templates define the categories of the items that editors are able to create. And they're based on specific configurations of the attributes. And they come along with a series of potentially types that then can also define symbology that's used with it. So this really comes down to its ways to be able to leverage parts of the platform to speed up data creation and data collection and have it done in a consistent way. If anybody's used subtypes, for example, in the geodatabase, they come across as these types. So it controls the domains, the attributes that you're able to select from and work with while you're running in the Runtime API. Again, by leveraging these, you can build customized user interfaces to help support easy data collection. Editor tracking is another capability that the feature service supports. With editor tracking, you keep track of the creation time, the creator, the editor, and then the last date and time for each of these operations. This works both online and offline, and that time would be either pushed back to the server when the apply edits is called or when synchronization happens. So the fields that are involved with this and the capabilities that are enabled on the layer are advertised with the layer info that's on the ArcGIS feature that comes from the feature table. As I said, it's configured on the services, and the runtime is just consuming it, not making changes to this. But we do things like filter out some of these fields when you go to get a list of all the fields for your attributes. So they don't pop up if you wanted to build a customized dynamic UI based off of the attributes that are exposed by a feature layer. We actually filter all those things out, and behind the scenes we take care of maintaining them and keeping them up to date. Ownership-based access control is really about restricting the capabilities that groups of users have on individual features or on layers of data. You need to have editor tracking enabled to be able to support this. On the service needs to have that enabled because it needs to have that identity of who is actually doing the editing or the creation to be able to figure out if they're actually allowed to be able to create or edit certain features. And again, all of this is taken care of by the runtime, but as the all this is taken care of by the runtime, but you do need to check permissions on the individual features, or check the capabilities, sorry, on the individual features to be able to see if you can add, can update, and can delete, and that's affected by the ownership-based access control. As mentioned earlier, when working with the ArcGIS features, we have the ability to include attachments on that. Capability enabled on the services, and this is really about attaching some kind of file. Usually it's a picture, but it can be any kind of file that you attach to your feature that brings along some additional data that's not suitable to store as attributes. There's additional properties on the feature that tells you if you can add, update, and delete, same set of operations on attachments. So to take a look at all of this stuff in a nice example, I'm going to turn it over to Eli to look at editing in an example tree survey app.
Thank you, Justin. My name is Eli. I work with the example apps team on the runtime team. And I'd like to demonstrate an application that we've been working on that allows you to edit your features that exist in an online backing service. So what you have here in the simulator is a tree survey application. This application contains a map that has every tree in a public space in the city of Portland, Oregon. So say I'm working for the city and I know that there's been a new tree planted. I'd like to actually add to this database. Let's run through what that would look like. First, I'll zoom to the street level. You can see that I'm in a neighborhood called Ladd's Addition. It's got a very interesting shape, if you ask me. And I'd like to add a tree that I know has been planted in the middle of the circle. So let's see, I'll click the Add Tree button and I'll drag until I think it was planted there. And select the location. You can see that I now have this form. I'll select a species. I know that this was an Oregon favorite. This was a Douglas fir. So let me find that. Here we are. I'm going to call the circle a large median with a site width of 50 feet. There are no wires overhead, and I planted it. So I'll save that tree. And next is it'll prompt me to add its first inspection, and I'll give it a tree condition of fair and a tree diameter of, let's say, 7 inches. And we'll skip the note for now. So adding that inspection, you can see when the map returns that right in the middle here, there's a yellow dot, and that represents the new tree that we just planted. And the yellow represents the symbology, reflects that of the tree's condition of the latest inspection that we just made. So what does that look like in code? How did we get here? So creating a feature is really easy. We've been talking about feature tables and feature layers. You need to, as long as you maintain a reference to your feature table, you use the create feature function, and it'll return to you an ArcGIS feature. So editing attributes for these features is also very easy. For instance, you saw me put my name in when we said who planted this tree. And you can see that you take the features attributes dictionary, and for a key, you give it a new value. In this case, it's a string value. It's really that easy. So now the tree feature, the local tree feature object, has not yet been persisted to the local geodatabase, nor has it been persisted to the online store. But it is an instantiated feature locally that we are now maintaining. So we'll come back to the application, and now we'll see, okay, let's make sure that the tree that I added was in fact the one that I wanted, and let's read the information again. Let's go back and see it. So querying at this location, you can see it did find that tree, and also you can see here, it found the species and it found the number of inspections, right? Both of those are related records, right? These exist on their own different feature table. Right? So we had to query for related records in order to find this, right? And you can see if we open it up, it gives us more. This is the table view that has all the inspections. Again, we only have one for this tree, and then more information about the tree itself. So how does this look in code? Come back to Xcode. And you can see all we need is just a few, to maintain references for a few things. First is the feature table, right? So in this case, say we are trying to find related records for the tree to species relation, right? So we'll maintain a reference to the tree feature table on which you can grab, it contains a reference to the layer information, and then on which you can grab an array of relationship informations, right? Iterating through that array, we just want to cross-reference if that relationship name is in fact the one that we're looking for, right? Because one feature table can have multiple relations to other tables, right? In this case, it's tree to species relation. So now we come down and we build a related query parameters with that relationship information. We have this parameters object, which we then take and using the tree feature table, we query related features for the tree that we just selected, passing in the parameters which contains the related query parameters. And we are given a response with optional results and error. If all things go well, we are provided with an array of feature objects, which then we can return back to the application and do with what you'd like. So let's say that I'm with my fellow city colleague, and they also did a measure of the tree and found that it's in fact a little bit larger than 7 inches. Let's just update it really quickly. So it was in fact 7.4, and they say it's good, and maybe because it's so small, I thought it was in fair condition only, but it's actually, for its size, it's a really healthy tree. So I'm going to update the condition as well. So I'll save that. And if we go back to the map, we should see that the symbology has been updated accordingly for the condition. And that is now persisted on our backing services. So again, what does this look like in code? So we'll come down to our inspection form. Again, you have an ArcGIS feature object, and changing values for the attributes dictionary, until you save that, until you update the table with that feature, they are just an ephemeral change to that feature object, right? Just a second. But if you take, for instance, we updated an inspection just now. If you take the inspection table and you run the update feature function, and then we provided also an edit closure, it then, after that is, it runs this closure here, and we are given a result. Hopefully there's no errors here. And once this has come back with no errors, the local geodatabase has been updated. And then we take the same feature table, the inspections table, and we apply edits so that we can then update the remote backing service as well. And again, whether a feature exists on a feature layer or a feature table, they're all just features. It's the same API no matter what. So anyways, thank you so much. This app will be available in short order, open source through our developers website.
All right, thank you, Eli. So Eli spent a bunch of time looking at editing of attributes. One of the other components we're editing is, of course, we want to be able to edit the geometries of our features as well. So one of the things that we have to be able to help work with editing geometries is a sketch editor. And what we're going to do is we're going to use the iOS example, the iOS Samples app to take a look at one of the samples that are there that's about sketching on the map. So if I fire up the sample, we can see that we have a really simple map and a nice little UI on the bottom of it where we can do things like create a geometry, I hope. There we go. And as I create my geometry, I also get lots of built-in capabilities, like I can come back over here and select this vertices and then move it around. I can add new ones to continue to reshape, or maybe if I didn't like that, I can undo, trash the whole thing. So quite a sophisticated UI and experience that you can build around editing geometries. It includes things like being able to move it, translate the whole thing from side to side, resize. There's lots of different things that you can do with this. And it actually doesn't take that much code to wire all of this up. If we switch over to the IDE, we can see all we had to do was new up a new sketch editor and then assign that to the sketch editor that is on the map view. Now, this is Swift code that we're looking at, but the same thing will be in each of our runtime APIs. We have a consistent set of classes and a consistent patterns that we use across all of them. So no matter what language you're used to looking at, you should be able to find the equivalent one there to work with it. Once the sketch editor has been assigned in the map view, I'm able to start it and either start it with no existing geometry if I want to create a new one and just give it a type of geometry I want to work with, or I could actually give it an existing geometry that I could actually do editing on. I then need to do a little bit of work to wire up my UI to respond to changes, if I can undo, can redo, deleting the geometry, the different types of geometry choices that we saw at the bottom of the screen, and wiring up the assorted buttons that we had on the bottom right. So that's interesting, but I didn't really like the fact that the vertices looked like they were blue. And I really wish they had a number on them. I want to customize this thing. I want to make it fit with the rest of the style of my app. And that's one of the things that you're able to do is change a number of properties on the sketch editor. So we'll see we have a whole list of different things that we can change here, and they're just symbols that we can set that will actually be used in these cases. They're just an ArcGIS symbol, just like all the other symbols we use for visualizing features. So we can change things like the fill symbols, the feedback, the line styles. All of this stuff is customizable. One of the easy things that we can change is the selection color. So let's say we want to set our selection color to blue. And then we also said something about let's change the style of our vertices to give a count. I think we can do that here somewhere. Yeah, how about we show some vertices and the number of them there and turn that property on. So now when we'll run the app, we're going to have a completely different, well, maybe not completely, we're going to have a slightly different look and feel to it. One of the other things that we can do is we can change to actually edit an existing line. So rather than starting off with a blank geometry, we'll go through, I've just created a really simple line that's going to stretch across the map, and then we'll actually use that to start our sketch editor with, so we'll be able to have that in an editing mode, and we can start to modify it. So as that fires back up, hopefully, we'll be able to see what that looks like.
We need music.
We need some music, some wait time music. That's, hey, at least it's not sync. That's taking a long time. How's your internet connection for your next part of the demo, Auntie? Is it going to work? And if I could spell, that would always help as well. So there we go. So we have that line that we actually started with, stretching across the map, going way across the map, and we can select our vertices. We see our outline color is different, and we can see that we now actually have all of our vertices numbered. I can move those, I can add new vertices in with the exact same experience that we had before. So, back to the presentation. So we took a quick look at how we were doing editing online. So editing starts with data and services in the cloud, in ArcGIS Online, and that's either powered by hosted data or potentially it's been authored in desktop and shared from your on-premise servers. That data is then requested by and sent down to the client as the client needs it. Eli showed us how we were able to, once we have those features, be able to edit, make changes to those attributes, which do get cached locally, and then when we're ready, we call apply edits to push those changes back up to the server. So this is the one pattern of working with data in that connected way and editing online. And what we're going to do now, and the key part of that is apply edits to make sure the changes get pushed up. So this is one pattern for working with data online. Now we're going to turn it over to Antti, who's going to talk about editing in offline scenarios.
Thanks. So in a case where we are doing the editing is exactly the same. It doesn't matter if you're doing online or offline editing. As we have been already said several times, it's just the feature table. You access the feature table as ArcGIS feature table, you get access to exactly the same functionality that you have when you are using feature services or local geodatabases. But the difference comes how you get the data into your device and how you synchronize that back. As the apply edits was mentioned already, and that's where the difference really starts to really kick in. So this looks very familiar from the previous chart as well. And here we get the data to somehow into our devices, and we are using the sync framework that we are having. And again, we can do local edits, and the difference here is that we can work with the sync geodatabase sync task or offline map sync task to handle the communication between any changes done on the server side and any local changes. And when we are doing the synchronization, we basically have three different options. We can download only the changes that has been occurred on the server side. No edits from my side is being sent to the server at that point. Or we can just send my edits to the server and we are not getting the latest changes back. Or we can do both at the same time. And these are the kind of the three major players in this game. And this allows you to optimize your workflow a little bit better. So if you don't need to get the changes from the server, you don't need to pay the payload downloading all the data or even generating the deltas on the server side. So how does the sync work? When we have the sync-enabled feature service, we can call generate the geodatabase from that. Then we can pull it down to offline. It gives us access to all the adds, edits, deletes. And then we can call sync to generate, and at that point we generate a local delta file. And that delta file only contains all the changes that we have done so far, and then we send that back to the service where it's originated. And after all the changes has applied on the server side, we get the response back if we have asked that we want one. And we download another delta file back to the device, and then we apply all the changes that was returned to our local geodatabase. So you work with the same geodatabase all the time from the programming point of view, and we extract stuff, send those to the services or a service, and we get the changes back, and then we just push them into exactly the same geodatabase.
So that's all the gory details of sync that you should never have to look at on a regular basis at all. These are the things that we had to do internally and how it works. But as a user, as Antti said, you just need to work with the geodatabase. The other thing about that is it also is fault tolerant in a number of those different scenarios. If deltas disappear, you can resync later and those changes don't go away. But don't be scared by the slide. It's not something you have to deal with all of those individual pieces.
I like details. Details are nice. But also when you are working with Sync, you have also the option to work with version geodatabases if you are running your own enterprise, ArcGIS Enterprise. And there you have a couple of different options how you can set the sync on. You can either generate a new versions per download map, or you can create a new version for each user who is accessing those services. But the big difference here is that when you are working with version geodatabases, you have to build your own back-end process to push the changes back to the default that you are working with. Automatically, the changes are not pushed there. So you have to do some extra work on the back-end to mash all the information back into the default. So let's jump to the editing demo on the .NET platform. So here I'm running a universal Windows platform, and I have a sample running that you can access already. Oh, it's again that one. I need to get rid of my presentation mode. Nope. There we go. And I have already created my local geodatabase, and I have accessed it. I opened the geodatabase and created a feature table from it and pushed that to my map. And here I have actually something that is totally new for 102 release, and that is working with transactions. So that's one of the differences that you can do when you are only working with local geodatabases. So I can just click editing, start editing, and it starts me a session. And on that session, I can go and add a couple marines over here and a birdie as well. And then when I click stop editing, I can get a feedback on do you want to commit these changes as a one single transaction into geodatabase, or do I want to roll it back? And if I roll it back, all the changes disappeared on my map. And let's do the same again. So I'll just put a marine over here, click stop edit and commit, and after that, as you can see, it stayed on the map. So as part of the 102 release, now you can actually start patching your local edits into a single transaction. It's really handy in cases where you need to do local business rules running. That is this, all the edits that I have done, are they still valid? And if something is not valid, then you can just roll back the edits if you like. But also, on the same geodatabase that I'm using, you can ignore the transaction if you want, and you can just do the single edits as Aili was showing earlier. So how does that look in code? So I'll just jump to Visual Studio, and here I have my local geodatabase instance. And I can check if my geodatabase is actually inside of transaction already. If it isn't, I just call begins transaction. And after this, I'm the only one that can access this geodatabase and do edits before either it's rolled back or the changes has been committed. After that, I had the add button, which is handled in this add new feature method. And I'm working with the sketch editor that is provided by my map view. This looks slightly different from the previous demo, because this is following the conventions that the .NET platform uses instead of the conventions that the iOS is using. And all the editing here is exactly the same. Creating a new feature, setting some values into my feature, setting like geometry over here, changing an attribute, and then pushing that to my table. And when I'm ending my transaction, this is where I get my feedback back, is that do I want to commit it or not? And if I say that yes, please commit, then I just call commit transaction on my geodatabase instance, and that makes the changes in. If I didn't want to do that, and I can just call rollback transaction, and it will roll back all the changes. Last part of the demo is synchronizing the changes back to the service. Where is my... So here I have my sync button, so I can just click sync, and that creates the delta, push that to the service, and my edits are there. And that is done by using geodatabase sync task. So we follow the general task pattern in our API, and this follows exactly the same paradigm over here. So I'm just creating a new task, providing the service URL in that I'm working with. Then I'm creating parameters for my sync task and hooking into the jobs changed event, which gives us a feedback on what state my progress is. And then I just call job get results async, and when it's finished, the synchronization is done. And that's how you work with the synchronization model. Let's go back to the slides. Let's see that it. As you can see, it's all new and fancy. So transaction is a really powerful tool that you can leverage when you are really starting to optimize your local editing and the process, how you want to handle all the edits when you are working with the offline data. And as I was mentioning, there is only one transaction at the time. So when you start the transaction, it locks all the other editing capabilities. So if you are editing the same geodatabase from your application in multiple places, make sure that you handle the transactions correctly. So in the past, we have been only working with a singular feature service. So we take one feature service offline, and then we work with it, and then we synchronize it back. But now we have a couple new workflows that has changed the thinking from the layer to thinking of the map. And this is something that we talked in the previous session, and we are talking more tomorrow afternoon if you missed that one. And that's where the pre-planned map areas and on-demand map areas comes handy. So instead of asking to generate or handling all the layers by yourself, you can just say that, okay, give me this map offline, and we handle all of that stuff for you. Either if you want to generate the data on the fly using on-demand, or if you already know the work areas where your offline users are, then you can use the pre-planned workflow to create the data on advance, and then you can just download it instead of generating it. And both of these are designed to work with the synchronization framework. And the geodatabase sync task, it has more options that you can do. So you have a little bit better control on what gets synchronized, what gets pulled down, than you have with the offline when you are working with the map. So in cases where you want to really optimize what's going on, then you work with the geodatabase sync task. But if you are just working with the map, that's where you can use the offline map sync task, which is came in 101 release. And the target for that is to just simplify the whole process of managing synchronization, and it's also designed to work with the offline map task that is used to take the map offline. And for that, I do have a demo here as well. So, okay, good, thanks. There we go. So here I have my application. I have loaded my online web map that has a couple changes already done after I have created the offline area using pre-planned. So look these 4 red bubbles in the middle. So I'm just downloading my area offline. And because this is now using the pre-planned workflow, so I just only need to download the data. So that's the reason why it's so fast. And when it finishes, there we go. We see that the points that I had in the middle, I'm missing those from my data set. So situation is that my backend processes were generating the data packages on Sunday evening, but on Monday morning, some other guys were already doing changes on the field. And I come to work on afternoon, as I normally do. So I'm already kind of behind on the changes that has happened on the live data. So I can use the offline map sync task to pull those changes to my local device, and there they are. So it's a very handy way to work with the whole map instead of singular layers. simplifies the code. And if we look how much code it actually needs to synchronize 2 different feature services containing tables and 9 different feature layers. Let's jump to here. And the code that I need to do is this one. So again, I'm creating a new task using offline map sync task, creating a parameters and passing in the model that I want to use. So in this case, I was just downloading changes, hooking into the progress, calling get results async, and when that's finished, all of my layers in my map has been updated. So hopefully that will simplify your workflows slightly. Let's jump back to the slides for a second.
Well, kind of disappointed, Antti. We didn't see a single crash. Sync worked every time flawlessly. That's far less exciting. That's far less exciting than when you were practicing it earlier and your service disappeared completely. Not the runtime's fault either. That's probably a configuration issue somewhere along the way. But not sure who you can blame that one on yet. But
IT.
IT, sure. That's all right. So. So we've talked a lot about a lot of stuff. I felt like we've talked about a lot so far this afternoon. There's a number of considerations that we do have to take into account when we're designing and building applications for editing data. And starting back at the very beginning where we did that brief overview of the API, where we took a look at there was a ArcGIS feature and a feature. And thinking about what you want to build against and how you want to design your UIs and what APIs you want to use, kind of bring in 2 different ways of doing things. Thinking about coding against specific services has fast to implement, and it can be very optimized for the specific data that you want to work with. But you trade that off against potentially not having as reusable set of code. So if you're going to be doing editing in multiple apps, thinking about leveraging the configuration that comes with the platform, thinking about using the features, using the elements on the ArcGIS features to be able to build reusable tools. Also, by building highly specific things, you potentially get into issues where it's not as tolerant for change. So if requirements change throughout the project, you're now rewriting code to deal with that, as opposed to changing configurations with your map. So there's just trade-offs. They both have pluses and minuses, but things to be thinking about as you go about designing apps and designing data to support those apps. So finally, a little bit on the licensing. For all of the editing capabilities that we looked at, these fall under the basic license level. So this is a license level that you need to have to be able to work with and edit data. And then one final, we have the tree survey app that Eli demoed to us. It's going to be released as one of our example apps. Our example apps are a set of fully functional applications that show off some of the best practices for working with the ArcGIS platform. They're open source, released on GitHub, then come up with a long write-up that we have on the developer site that tells you about how to use those apps, how to customize those apps for your own workflow. So we really looked at them as a starting point for you in your work that you're doing. And the app that Eli was looking at is going to be released hopefully sometime in the spring of this year. And with that, thank you very much for attending. Please rate our session in the app. There is a way to be able to rate. All that information, all that feedback that you give to us really helps us figure out what we're going to do next year. So please go there. And we've got some time for some questions. Or does everybody just want to get to the party? Sure.
Can you describe the difference with the versioning database? What you have to do to sync offline version?
Yeah, so the question was about versioning and what's the differences and what do you have to do there. From the runtime standpoint, actually the synchronization is the same. You still just call sync, but the changes are more on your back-end process. And there's a way, when you publish the service, you get a choice of do you want to have a version per map or per user? And that feeds into, you'll have to have a system for doing the reconciliation and post of those versions to move them back into the parent. So, but in terms of consuming in the runtime API, it's the same API, no difference there at all. There was one, yes? So the question was, for what platforms will the example apps come out for? So for the tree survey app, this kind of prototypical data collection app, that's going to come out for all of our APIs. We're going to see it across the board. And that's really the goal for most of the apps. We'll do some specialty ones that fit in better on one particular platform because they leverage something very specific about that platform. But generally speaking, and especially for the ones that are kind of the basics, data collection, viewing maps, working with portals, we'll have apps that will be on all of the platforms for those. Yes? So the question was, does the editor tracking track a history of that? It just tracks the latest one. So it just maintains the last editor and the last updated time for that. Any other questions? Oh, yes. What about Xamarin? What would you like to know about Xamarin? Antti, would you like to answer? You're the enthusiastic one about .NET, so.
It's the same deal. So all the code that you saw earlier and all the functionality is available in all our SDKs. Xamarin is just part of the .NET SDK that we have, and yeah, so it's available in all the platforms, Xamarin included.
I think with that, we'll end it, but we'll hang around here. If anybody else has more questions, please come see us. And thank you very much for attending, and have a good evening.